KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss Huygens principle. In our last class, we started this chapter wave optics. So in our previous class, we discussed what is the contribution from Newton's corpuscular theory of light, next Huygens wave theory of light and Maxwell electromagnetic theory. According to Newton's corpuscular theory, light ray consists of corpuscles, which are small massive particles. After that, light follows reflection and refraction, but in case of refraction, there itself we received light ray bends towards the normal, then the speed of light would be greater in the second medium. After this, Huygens came into the picture with a different idea, that is, light travels in the form of waves from one point to another point. With this idea also, reflection and refraction properties were satisfied, but in case of refraction, some contradiction, that is, the wave bends towards the normal, then the speed of light would be less in the second medium. So this point is contradiction to the corpuscular model of light. But anyhow, if you go to the practical, the information regarding the bending of light given by Huygens were proved correct. That is what light ray bends towards the normal, then the speed of light would be less in the second medium. To understand this, we already discussed in case of previous chapter ray optics, what is refraction, right? How a light ray bends when it enters from one optical medium to another optical medium, right? So either from optically rarer medium to the denser medium, or from optically denser medium to the optically rarer medium, what happens? We already got an idea, right? So based on that, if you see contribution of Newton's corpuscular model of light and Huygens wave theory of light, there is a contradiction, that the information there itself, the information given according to the Huygens wave theory were correct. Okay, right. But at the same time, according to Huygens, light travels from one point to another point in the form of wave. But there itself, one more point is, for the propagation of wave, there is a requirement of medium. There is a requirement of medium. But in practical, if you see the light, that is the natural, from surface of sun to the surface of earth, we can expect, we have to believe that, we have to assume that, and we have to see that practically, light is traveling even in vacuum also. But according to Huygens wave theory, we need to believe, we need to see that for the propagation of wave it requires a medium, but from surface of sun to the surface of earth, light is traveling through vacuum also, right? So here itself, Maxwell came into the picture he successfully explained the propagation of light in vacuum. So, we can call it as Maxwell electromagnetic theory. According to Maxwell, light ray is an electromagnetic wave. According to Maxwell, light ray is an electromagnetic wave. So, which consists of, light ray consists of oscillating electric field and oscillating magnetic field, which are oscillating perpendicular to each other and also perpendicular to the direction of propagation of light. I mean direction of propagation of light wave, right? Afterwards, we came to know, we already got the speed of light from electromagnetic theory also. So, he measured the speed of light also. That is also equal to the speed of light what we calculated practically, right? So, this is the information we received, we discussed in our previous class, that is first class from this chapter, wave optics. Okay, ma? Right. In continuation to that, in this class we are going to discuss about Huygens principle. Huygens principle. Okay, right. So, who is Huygens? What is his contribution? I already told you in this class itself. First, I told you the contribution from Newton's corpuscular theory of light. Then, I told you the contribution or information from Huygens wave theory of light. Then, I told you information from Maxwell theory of light, Maxwell electromagnetic theory of light also. Now, you keep in mind the information came from Huygens wave theory of light. Okay. In continuation to that, now we are going to discuss Huygens principle. Huygens principle. Okay, right. Listen carefully. See this. When we drop a small stone on a calm pool of water, waves spread out from the point of impact. Every point on the surface starts oscillating with the time. Full stop. At any instant, a photograph of the surface would show circular rings on which the disturbance is maximum. Right? Clearly, all points on such a circle are oscillating in phase because they are at the same distance from the source. This is the situation what happened in our daily life. So, from here to here, from here to here, it is the situation what happened in our daily life. He is explaining the thing what's going on, what's happened in our daily life. You please understand. If you understand this situation, based on that, we can understand what is a wavefront, what is a wave, what is the phase difference, what is the amplitude, right? What is meant by spherical wave, what is meant by plane wave, that and all I will explain you based on this situation. That's why again I will explain you the situation. You please be concentrate and try to understand. Okay, see this. So, this is the situation we came across in our daily life. Generally, when we go outside means when we go to the field. Okay, so there is a pond, otherwise there is a lake. Okay, otherwise there is some sort of source of water. Then generally we are going to throw a stone. So, this is belongs to that particular incident. See here. When we drop a small stone on a calm pool of water, waves spread out from the point of impact. Full stop. Every point on the surface starts oscillating with time. At any instant, a photograph of the surface would show circular rings on which the disturbance is maximum. Clearly, all points on such a circle are oscillating in phase, means same phase. because they are at the same distance from the source. Okay. So here what I am saying is, on that particular a calm pool of water, just you are going to drop a stone. You are going to drop or you are going to throw a small stone. Then what will happen? That stone, whatever you are going to throw, has kinetic energy. The kinetic energy of the stone, whenever the stone touches any one of the particle, any one of the water molecule, that particular water molecule receives the kinetic energy of the stone. Then that particular water molecule goes down. Then it starts to oscillate about its mean position. Mean position means the position of the water molecule before receiving the kinetic energy from the stone. Okay. When it starts to oscillate, that is the disturbance created among the water molecules. So when it starts to oscillate, that energy will supplied to the neighboring water molecule also. Then that energy is also supplied to the next neighboring molecule. Then that energy is also supplied to the next neighboring molecule. So like this, the energy transferred from one molecule to the next neighboring molecule, and so on. So that you can see the oscillation of water molecules up to certain distance or for certain interval of time. This is the situation happens when you are going to throw a small stone onto the surface of water, onto the calm pool of water. Okay, right. So now I am going to continue the next thing, right? See this. So in our first year syllabus, in our first year CBSE first year syllabus, we understood from the last chapter, oscillations and waves, we discussed what is meant by amplitude. So amplitude is the maximum displacement of a particle from its mean position. We also discussed what is meant by frequency. Frequency is the number of oscillations or number of vibrations made by a particle in 1 second. Then what is phase? Phase gives the state of vibration of a particle. Phase gives the state of vibration of a particle. Then what is time period? Time period is the time taken by a particle to complete one oscillation. Okay. Next, what is wavelength? Wavelength is the distance between consecutive crest and trough. The distance, wavelength is the distance between two consecutive crests or trough. Okay, that is. So these are the definitions already we came across in our first year chapter, oscillations and waves. All those definitions we need here to understand the things what I am going to explain. See here, such a locus point, right? Such a locus of points which oscillates, such a locus of points which oscillates in phase is called a wave front, which called a wave front. Okay, which called a wave front. See this. Here what I am saying is, such a locus of points which oscillates in phase is called a wave front. Here you can see ma. So this is what locus of all the points, such a locus of points, right? This is the origin. This is the origin where the throwing stone touch the water molecule, right? Afterwards, if you see that it goes down and the neighboring molecule comes up like that. So like that you can see this is the one. So which is the locus of points which oscillates in phase, right, is called a wave front, which is a spherical wave front because of having the shape, that is what, a sphere. That's why it is a spherical wave front. Next, see this. The speed, Thus a wavefront is defined as a source of constant phase, because here for seeing you are feeling like a circular line, a circle, but you need not to see this one ma, you just see otherwise you see this one, whatever it may be, right? So here everything is, suppose you see the red light, it is one water molecule. See now red light, it is another water molecule, another water molecule, another water molecule, like that. These are all water molecules, but all are oscillating in one phase, all are vibrating or oscillating in the same phase. So that's why here such a locus of points which oscillate in phase is called a wavefront. This is the wavefront. This is another wavefront. This is also wavefront. Just you see that circular line, okay? But on the board I drew only two-dimensional this picture, but actually it is a spherical wavefront. Sphere is three-dimensional, so it is a spherical wavefront. See this. Thus a wavefront is defined as a source of constant phase. A source of constant phase. Full stop. The speed with which the wavefront moves outwards from the source is called the speed of the wave, right? So as simple as such, speed of the wavefront is speed of the wave. That's it. Next, the energy of the wave travels in a direction perpendicular to the wavefront. It is the next important point. The energy of the wave travels in a direction perpendicular to the wavefront. Perpendicular to the wavefront. Okay, right. Next, if we have a point source emitting waves uniformly in all directions, then locus of points which have the same amplitude and vibrate in the same phase are spheres, and we have what is known as spherical wave. See here he extended the discussion to all the directions. Here he considered only one particular direction, but here the same discussion he is extended to all the directions, right? So if you see all the directions, then it is simply called as wave, spherical wave, right? That is. So I'll repeat once again. If we have a point source emanating waves uniformly in all directions, then the locus of points which have the same amplitude, and vibrate in the same phase are spheres, and we have what is known as a spherical wave as shown in figure, right? So this is that one. Next, at a large distance from the source, a small portion of the sphere can be considered as a plane, and we have what is known as plane wave. Suppose here the wave is originated ma, so it is like first one, second one, third one, and so on. No, suppose from here to here, right? Otherwise from here to some other in this direction, right? So if you go at the large distance, then what will happen? You can see the amplitude is going to decrease, right? So the amplitude is going to decrease, and you can see the plane wave, right? So you have to observe. So whatever I am saying, that you have to imagine, right? So here you can see, but here the role of air molecules also present. The role of air molecules is also present. Suppose if there is no air, if there is no friction due to the air molecules, then the situation will be different. But here I am saying that because of having air molecules, you can see at certain distance this will be like this spherical will become as a plane, and we have what is known as a plane wave. Okay, it is known as plane wave. Okay, afterwards see this, after completion of that, see here. So it is what you can see that plane wave, right? So you see this information ma, diverging spherical wave front emanating from a point source. The wave fronts are spherical. Next here, see this, at a large distance from the source, a small portion of the spherical wave can be approximated by a plane wave. Okay, right. So till now we discussed what is wavefront and what is wave, when the spherical wave is present, and after what time or after what distance the plane wavefront will be available, or when it is going to just changes the shape from sphere to plane, that we discussed. Okay. Now we are going to discuss Huygens principle. Huygens principle. Okay, right. So what is the main use of Huygens principle means? If you know the shape of the wavefront at a time is equal to 0, then you can determine the shape of the wavefront at a later time tau. That is possible because of Huygens principle. Because of Huygens principle. Okay, see here. So actually it is a geometrical construction which gives the shape of the wavefront at any time. Okay. For example, here you can see at t is equal to 0. At t is equal to 0, you see the light f1, f2. This is the wavefront. At t is equal to 0, f1, f2 is the wavefront. f1, f2 represent a portion of spherical wavefront at t is equal to 0. At t is equal to tau. T is equal to tau means after certain time, that is tau. This is the wavefront. It is the spherical wavefront, that is G1, G2. That is G1, G2. Okay, right. So what is Huygens principle? According to the Huygens principle, or by using the Huygens principle, we can determine the shape of the wavefront after certain time. After certain time. Okay. Now I am going to give you information about Huygens principle clearly. See this. According to Huygens principle, each point of the wavefront is the source of secondary disturbance, and the wavelets emanating from these points spread out in all directions with the speed of wave. These wavelets emanating from the wavefront are usually referred to as secondary wavelets. And if we draw a common tangent to all these spheres, we obtain a new position of wavefront at a later time. New position of wavefront at a later time. Okay. So this is the new position of wavefront. It is the first. So what he is saying is, according to Huygens principle, each point of the wavefront, suppose this is the wavefront at time t is equal to 0, no? Let me take 2 or 3 points for our convenience, right? These are the 3 points. Let us imagine, right? So from these 3 points, and these 3 points acts as a source of secondary wave, source of secondary disturbance, and source for secondary wavelets. So here again, see, this is the source, no? So from here the initial one, and the secondary one, and the third one. But at the same time, for example, if we have taken these 3 points on this wavefront, and again this will act as the source of secondary wave. So like this. This one will act as a source of secondary like this. This one like that. So like that it will continue. It will continue to move. Okay. So that only he is saying here. According to Huygens principle, each point of the wavefront is the source of secondary wavefront, is the source of secondary disturbance, and the wavelets emanating from the points spread out in all directions with the speed of wave. These wavelets emanating from the wavefront are usually referred to as secondary wavelets. And if you draw a common tangent to all these spheres, we obtain the new position of the wavefront at a later time. Okay, right. So I already told you, this is the wavefront at time t is equal to 0. It is the wavefront at time t is equal to tau. In our discussion just before 2 minutes, I told you speed of the wavefront is nothing but speed of wave. So here suppose you just imagine v is the speed of the wave, means v into tau. V into tau is the distance travelled by a wavefront in tau seconds. In tau seconds. Okay. So this is the distance travelled by the wavefront. So here you can see another one. right? So here the shape is spherical and here also the shape is spherical. So this is possible to know by using Huygens principle. Huygens principle. Okay. See, if you want to determine shape of the wavefront at t is equal to tau, we draw spheres of radius like this now. Spheres of radius v into tau from each point on the spherical wavefront. From each point on the spherical wavefront. So from here, from here, like this. So like this everywhere you have to draw. Then finally you will get this one. This is right. So we have to draw like that. And afterwards, nu represents, that is what ma, speed of the waves. This is the speed of the waves. And if you now draw the common tangent to all these spheres, we obtain a new position of the wavefront. This is the new position of the wavefront. Suppose here it is a tangent, and here it is the tangent, and here it is the tangent. For our convenience we took 2 or 3, but there are n number. Every point we need to draw the tangent. Then you will get a new wavefront, that is what, G1, G2. G1, G2, okay, right. Here one more important point is, here this model has one important point, that is a back wave, that is the discussion about the back wave. We also have a back wave which is d1, d2 here. So d1, d2 is called as back wave. Huygens argued that the amplitude of the secondary wavelets is maximum in the forward direction and 0 in the backward direction. So this is what one of the assumption from Huygens model. Huygens could explain the absence of the back wave. However, this assumption is not satisfactory and the absence of the back wave is really justified from wave theory. Okay. So till now I explained according to Huygens principle how next wavefront, I mean after certain time t is equal to tau, how the wavefront is going to generate or how the wavefront is going to form. It is a wavefront at t is equal to 0 and it is a wavefront at t is equal to tau, just by drawing a lines, because v is the speed of the wavefront or wave and tau is the time, you are getting G1, G2, that is after this is F1, F2 at t is equal to 0. So it is at t is equal to 0, it is at t is equal to tau. Okay. In this manner we can also determine shape of the wavefront for a plane wave propagating through a medium. So this is what plane wave, like A1, B1, C1, D1 are the 4 points, and here you can expect the next wave, that is at t is equal to tau. So it is the plane wave at t is equal to 0, it is the plane wave at t is equal to tau. Okay. So this is all about in this class Huygens principle. We focused on Huygens principle. In this class initially I explained you what is a wavefront, then I explained you what is a wave. Afterwards I told you when the wavefront is spherical, when the wavefront is plane. Afterwards I went to explain you about Huygens principle and what is the use of Huygens principle and how it is possible to know the shape of the wavefront after certain time. If you know the shape at time t is equal to 0, after certain time, for example at t is equal to tau seconds, what is the shape of the wavefront? How it is possible to know, either in case of spherical or in case of plane. So we will continue in the next class with refraction and reflection of plane waves using Huygens principle. Okay ma? Right. Thank you.